Thank you, sir. All right, so I will go through this one, even though I just ranted about it. So this is our steps that we did yesterday, where our first step is to factor as much as possible of our denominators. That's a weird way to write. There we go. So the first term, there's not really anything I can do to simplify here, nor here. But this one I can factor. So we can write this last term. This is a difference of squares. You can either think of our x in frame multiplies to be -4, adds to be 0, or you can remember our difference of squares pattern, where it's x plus 2, x minus 2. And then it's like you could factor the numerator, but we know we're going to be adding and subtracting and combining like terms on stuff, so I'm not going to factor numerators. We're only factoring denominators. My left two pieces, I'm going to leave the same. I'm just going to give them a little bit of space so that we can deal with our multiplication step next. So I'm going to keep my x minus 2, and I'm going to have my 7 over x plus 2. So I'm just taking all of those pieces. Our second step from yesterday was to multiply by the least common denominator. So what is our least common denominator? X plus 2 and x minus 2. Those are the only pieces in the bottom. I've got an x plus 2, I've got an x minus 2. I've got an x plus 2, I've got an x minus 2. I only need one of each of them. But everything that exists in the denominator is what we're going to have. So then I'm going to multiply every single term by that least common denominator. So I'm going to multiply the 7 times x plus 2, x minus 2. This 5 term, x plus 2, x minus 2. And then the right-hand side, x plus 2, x minus 2. Then we're going to come through and simplify things. We're going to cancel stuff out as best we can. So on this one, what can we do to simplify? Cancel out the x plus 2s. We're going to be left with 7 times x minus 2. On this term, what can we do? The x minus 2s are going to cancel out, and we're going to be left with 5 times x plus 2. Then we're going to look at our last term, and what's going to cancel out? Everything. The x plus 2s, the x minus 2s. So we're left with just our 10x minus 2. So now in order to finish solving this, because that's our next step, would be to simplify, which we just did, and solve. So we're going to do all these distributions. We're going to wind up with our 7x minus 14 plus 5x plus 10 equals 10x minus 2. Combine our pieces together, combine our like terms together, and we're going to have 12x minus 4 equals 10x minus 2. finish solving this out by subtracting 10x from both sides and adding 4 to both sides to get that 2x equals 2, which means x equals 1. Nope. Love that. My screen did the freezy thing again. So much fun. My software turns into a jerk. No, I promise you have an internet connection. Just connect. That is a 12x. That was the 7x plus the 5x. There we go. Our last piece is we have to check our answer. And the easy way to check our answer is to double check that when we substitute this in, my denominator is never 0. That rules out any removable discontinuities as well as the asymptote. So it lets us check everything. So if I substitute 1 in for x, is my denominator 0? Nope. If I sub my 1 in for x, is my denominator 0? Nope. If I sub 1 in for x, is my denominator 0? Nope. So this is an actual solution. This is a valid solution. We checked it. We don't care what the other part of the solution is, just that it works. Okay, so today we're going to do more solving stuff, but not so much like this. Like, these don't get worse. We've done the worst of these yesterday. What throws us off when we're working with our solving stuff is we're actually going to focus on story problems. So we're going to have problems like this. So I'm going to give you guys a chance to write it down because I did not do any printing out on this one. So we've got that Joe can paint a house in 3 hours, and Sam could paint that same house in 5 hours. So we want to know how long it takes them to paint the house together. And our instinct is to just add them together, 3 plus 5, surely. But does it make sense for them to take more time when they work together? No. So it should be faster. It's also not going to be the difference between them. So we have to look at this in a different way. What we're going to do is we're going to make these like speeds or rates or slopes. So we're going to think about in like miles per hour. But in this case, it's going to be houses per hour. So Joe can paint one house per 3 hours. And Sam can paint the house in 5 hours. So Sam can do one house in 5 hours. Oh my gosh, pen? Seriously? There we go. So we want to know if they work together. So if we add their work together, combined, they can paint one house in some number. I don't know that, so we're going to use a variable of hours. So I set it up using all the words, and I swear the word house looks like it's spelled wrong every single time. So I like to set it up with the words first, and then I can look through and say, well, this is just 1/3 plus 1/5 equals 1 over what? So I write it down with the words so I make sure everything gets put in its right spots because we want all of our houses lined up and we want all of our hours lined up. And then I'll drop all the words so it becomes something we can solve. And then we're going to solve it the same way we did the bell work and all of our things yesterday. There's nothing I can do to factor here, so we're going to find our least common denominator of all these pieces. So what is our least common denominator of all of these pieces going to be? Definitely part of it. What else is in the denominator? The 3, the 5, and x. So our least common denominator is going to be 15x. Or you can write it as 3 times 5 times x. Like, that is equally as valid. And so then just like we did yesterday, we're going to multiply every term by that least common denominator. So I'm going to have my 1/3 times 15x, my 1/5 times 15x, and our 1 over x times 15x. Multiply every piece. Then we're going to come through and we're going to simplify. On this first term, if I have 1/3 times 15x, what are we going to have left over? How is this going to simplify? 5x. If I have 1/5 times 15x, 3x, good. And 1 over x times 15x. Just 15. Yeah. Because my x is canceled out here. So now we can solve this. Now I can figure out what x is. I'm going to start with combining my like terms. I've got 5x and 3x. That's going to give me 8x equals 15. What do I do to get x by itself? Divide by 8. So we're going to wind up with x equals 15 divided by 8. Which is great, but not super helpful if I'm talking about like time. I don't know what 15/8 of an hour is. But we can put it as a decimal by typing that in the calculator and getting 1.875 what? What is our x again? 1.875 what's? Hours. When in doubt, look up at the one you wrote out with words, and that gives you your label right here. Wherever your x is, it's got the label next to it, which is one of the reasons I wrote it in words first. Always an excellent choice to look at it at the end and say, does that answer make sense? Is it going to take them less than each of their times if they work together? Yeah, it should be shorter than the 3 hours, and it should definitely be shorter than the 5 hours for them to work together. So look at it with a critical eye and make sure it makes sense, because it's really easy to get things kind of confuddled. But that's how these story problems kind of go. Questions on this one? Okay. Then let's do another one. So we've got another totally relevant and absolutely real life story here. Sorry, my screen's freaking out. We've got that Terrence had a party at his house and it took him 4 hours to clean. And the next weekend his brother Jamal threw a party and only took him 2.5 hours to clean. And we want to know, if they worked together, how quickly could they clean up their house before their parents got back home? So we start by writing the pieces we know. I know that Terrence took 4 hours to clean the house. So Terrence can clean one house per 4 hours. And Jamal, can clean the house in 2.5 hours. So Jamal can clean one house per 2.5 hours. We want to know if they work together. So working together means I'm going to add theirs together. It's not always going to be an addition thing. Sometimes they're going to be fighting each other about it. But if they're working together, we add it. We want to know if they work together, they could combine, do one house in how many hours? So what we're really looking at here, our equation is really 1/4 plus 1 over 2.5 equals 1 over x. That's the equation we're solving. So again, I write it out with my words before I try and solve it. It makes your life easier. So our next piece then is to find our least common denominator. What is our least common denominator going to be here? 4 times 2.5 times x, which is, I heard you have it, Levi, there, 10x. So I'm going to multiply all these pieces by 10x times 10x times 10x. We multiply each of the pieces by that least common denominator. Then we're going to simplify. If we just look at this piece, it's a little harder to spot, but 10 divided by 4 is going to be our 2.5. So this is going to give us 2.5x plus 2.5 times 10, or I'm sorry, 10 divided by 2.5 is going to give us 4x, and that's going to equal 10. Ten divided by 2.5 is 4. 10 divided by 4 is 2.5. Then we're going to add those together. So 2.5 plus 4x. Yes, sir. I took this up here, when we multiplied all these pieces, and I simplified them. 10 divided by 4 gives me 2.5. 10 divided by 2.5 gives me 4. And these x's are still here. So we took our equation and we multiplied it by our least common denominator, and then we simplified. So we're going to add these pieces together. 2.5x plus 4x gives me 6.5x equals 10. What's our x going to be? 1.538, blah, 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 blah. 1.538 what's? Hours. So if they would just, you know, stop fighting and work together, they'd get the house cleaned in an hour and a half. So don't make enemies with your siblings. Yeah, let me write you a pass. Give me a second. Okay, so we're going to do another one of these. But questions on this one? Okay. This is our last one for today. All right, so we've got, it takes Sam 25 minutes to eat a bag of Cheetos. When Sam and Dean eat together, it only takes them 14 minutes. And then randomly, we're asking about a Dylan. Dylan's not in there, it's Dean. Because supernatural. Huzzah. So I'm just going to fix that name. So we're not asking about a mysterious third person. So this one is slightly different in structure. I know Sam's rate and I know the combined rate. We're going to try and find Dean. So we're still going to start out the same kind of way. We're still going to start out with writing Sam's fraction. So Sam will eat one bag in 25 minutes. So for Sam, it's one bag per 25 minutes. Usually we would take Sam and Dean and add them together. But I don't know anything about Dean's rate. I don't know how long it takes him. So we know he's going to eat one bag, but we don't know how many minutes. So we're going to use our variable. So it's going to be X minutes. Because what I do know is that combined, they will eat one bag in 14 minutes. So it's just slightly different. We're going to treat this the exact same way, though. We're still going to find our lowest common denominator. We're still going to multiply it, and we're going to solve for x. It's just slightly in a different place. So let's look at this and figure out what is our least common denominator. Let me write it without our words in there. So we're going to have 1 over 25 plus 1 over x equals 1 over 14. what pieces do we have in our denominators? 25, 14, and x. And if it helps, you can just write it like that. It might make it easier, especially since we're going to have a bunch of simplifying to go on here. So I'm going to just do it that way. So we're going to multiply everything by 25, by 14, by x. By 25, 14, x. 25, 14, x. Thanks, Jordan. So writing it this way, especially when our numbers are a little bit obnoxious, actually makes it easier for simplifying because I can see really easy that these 25s are going to cancel out. And it's going to be 14x. My second term, it's the x's that cancel out, and we're left with 25 times 14, which is 350. And that's going to equal, here my 14s cancel out, so we have 25x. So what are we going to need to do to solve this? Subtract 14x from both sides. Get those x's together. So we have 350 equals 25 minus 14 is 11x. So what is x? 31.81. 31.81 what? Minutes. Make sure you put your labels back on them. Okay, so the story problem, math is not harder. We just have to wrap our brains around the fact that we're writing ratios instead of like equations. Okay? So you guys have almost 10 minutes. You can work on homework 9-6. We're going to do a few more story problems on Monday just because these they're a little weird and they take some getting used to. So we're going to do more on Monday. They're not worse. They're just different. So you can work on 9-6. You can work on catching up on other stuff. Our test is next Wednesday. I do have the review. If you're one of those people that likes to work on the review over the weekends, I'll put them up on the table in the front. And you guys can grab one. You can have it. You don't have to take it today. We're going to work on them Tuesday. Yeah. So review's up on the front table. If you want it, you're welcome to it. You do not have to have it today. I'll also have them available for you guys Monday, but I know some people like to work over the weekends.